So finally, can I do a combination of chalk talk and some slides?
Absolutely. We'll start probably around 12:30.
Great, yeah.
Wow, you don't even have to stand up.
You've got yourself.
I'm trying to screencast it, so it's just useful. And then also someone from the lab might just listen in. Basically, if I'm going to do it anyway, might as well make it real.
So I forgot to approve the year's email earlier.
Oh.
Anyone
Oh.
get?
So you have to like.
No,
actually
so I
approve
think
one,
his email wasn't on the list.
Oh, I see.
And
Sorry.
like it's some other, and then he wrote it from the
Yeah.
email, I didn't notice it.
Right.
You know,
No,
anyone?
it's out of control. Yeah. I'm waiting for it.
Okay. Yeah. No, it shouldn't, so that's one thing that's actually on my to-do list is I think it makes sense for us to maybe do one more round of like, whatever emails you want on that list, like send it to Michaela. So if you use like both your Harvard email and
Right.
your email, you don't get a bounce because. There.
Yeah. Oh no! How bad is damage?
25%.
Okay.
And that's no like I failed on your before.
We were just discussing yesterday that there's a good work problem. That's but it's handle charts, right? So it's fine.
Yeah, it's 200 anchor. Yeah, no, so, but that crop was looking like 700 anchor.
And so there's all the grains being off the ground and they're happy like that.
Yeah, there's, I mean, there's like,
Yeah. It's great use of bulbs.
yeah, exactly.
Yeah.
That's how it is.
Is it cold though, or is it just like a summer hailstorm like we had?
I think, I don't know what it's like, but when I was there for a week, it was like nice and warm. A lot of thunderstorms.
Yeah. But lucky these mechanisms like insurance exist to smooth that these.
Yeah.
There's
Obviously, like, you guys don't know, you need to know about this. But, I just found out right now when we were talking about it yesterday.
Very clear.
And just outside of Winnipeg, Manitoba.
the hail affect cattle on the ranch.
No, it's
There's
not
cattle.
really. If they're big enough, yes. But if they're big enough to hurt the cows, then you can get other issues.
Probably shows it on the
You're right.
Yeah.
Like I was mentioning some of the new students yesterday, but
Yeah.
like, we talked to them, they didn't even know what that was.
Yeah,
They didn't know what it was.
you know what it was, yeah.
Okay, nice.
It's a state.
Province.
Province.
But I mean, it's an analogous thing. See what, I don't know if there's any.
Are they states and provinces in Canada? What about those?
Provinces and territories. Don't worry about it.
Well, I think the word state in the United States from states being independent governing units.
Yeah,
Because it used to be independent governing units, and that's like United States.
Yeah, it's already as well.
The states is technically independent.
yeah, but then, so I get that, but then now that there is a federal government, a strong federal government, it's not there where it's anything anymore.
Anything anymore. That's the history. like where's Canada was always one unit that has provinces.
I see.
Or was settled as Canada.
There's a bunch of different things. And there's like French Canada. And, like,
Right, or here.
it's different from it's like, it's
The
owned by a company
the
for a while.
English part.
Yeah,
Or
like,
British
I
part.
think the company owned by like most of Canada. These are the big things.
I guess like, yeah, match and behavior about that rather than something that would like.
I'm saying this. I haven't even touched on that before.
When do you earn and get back?
Sure. Never just started this year.
Yeah. Does she know that?
She does. But today is their C's, no, yes.
That's stuff through that.
I feel like if I was a grad student, I'd be like, just don't bother, but I feel like as a professor, it's a little more.
With Cambridge, there was this like mandatory safety thing about like how to use lasers and ladders and stuff. And I remember Sinead managed to not do it her entire PhD and got even like your emails for the entire PhD said you have to do this. She just ignored every single one.
I think I also ignored all of this, but I don't know, I played the stupid American card so many times. While I was there.
But then the other day, people was asking, where's the first aid kit? And I was like, yeah, I never had orientation. I just put them.
Well, apparently yesterday, there was a mandatory safety regulations and policies. Whatever was telling me.
But she was telling me that they never told her about the fire extinguishers were, but that you would know.
Sure.
First aid. That's
Yeah.
Basic.
I would go ask Meg or
Yeah.
my admin
I just
downstairs.
had like a cut the sleeve.
They have like those boxes of stuff to show.
Who's coming next?
Who's coming and from the team?
Okay.
Yeah, maybe we'll go downstairs just in case they, I think they do like number, but
Oh, I didn't realize there was a bonus of food. Okay.
How was the public data conference?
I was only around from the first day, and it was, yeah, it was good. So David Johnson gave a talk about his cool sort of like Wasserstein list and stuff, and I'm kind of a fan of this idea that he's been sort of harping on how to use distributed inference. And
This is like bias and
what's up?
this is bias and
This is basically, so he has two of them, right? So he talked about that too,
okay.
but his, what he talked about was, first was this like idea of, you run a bunch of, you run a bunch of independent chains, completely independent on different subsets of data, and then they kind of like, essentially like.
Oh yeah, for sure. I mean, if you don't mind, yeah, it'd be great to get your thoughts.
So each of them sort of produces
Talking about your research.
Yeah. Yeah, it'd be great.
Can you get my lunch?
If you imagine
They actually got lunch. Lunch is coming at 12:15.
very center on Earth,
So it's coming.
Yeah, exactly.
which turns out to be the like Wasserstein 2 norm, that thing has a useful relationship with it's like not going to be that far from the true cluster.
Oh wait, this isn't talk about action here.
Yeah, I think we talked about it a while back. Yeah, I think it's a little bit better developed now.
Okay.
It's kind of like a median under this like Wasserstein 2, and and it's kind of like a nice idea, right? It's like what's the right way to collapse these different independent postures into the one that is as though you saw all of them. And then Mike Jordan gave a talk also, that was like nothing interesting. And he was kind of talking about, he talked at a very high level about, he talked at a very high level about kind of these, trade-offs between statistical estimation and computation, but didn't really get into much sort of detail about anything interesting. I'm not sure. Obviously, it's not that much. Anyway, I enjoyed tons of stuff.
This is in the paper on iPad. I think I'm going to talk about it in my talk next week.
Yeah.
But it was saying when the variation inference produces the correct possibility. And there was something for LDA saying that when you have anchor words, then some sort of like factorized like SBI thing gives you the like covers the correct population. Yeah. Yeah, I haven't read it yet, but it just seemed like, it always bothered me that there was these tricks that you could use in this sort of model-based setting, and there didn't really seem clear how to exploit them. Yeah, so it's kind of like whenever there's like a really good non-vision method, I'm always like, there's gotta be a way, right? And then so it's just nice.
Now that you mention it, it seems like you could just do it. And so what are your I don't know how to do it.
Yeah, I think you're just running the standard. I guess that LDA already does.
This is just what's up on my screen.
Yeah, under
How's
the
your grant
assumption that
proposal working?
It went in, so it's great. It's done.
whatever the
Yeah.
same assumption is.
So now it's
Which,
it was for
It's
the
on the
Department of Education. It's interesting to create an online learning research center. So lots of everyone applies, but it's cross our fingers and hope.
you can apply for grants, or
Neil Huffman applied, so I'm
help.
exactly, and he's very good. I mean, we work very close together. So he got me a position as a research scientist at Worcester Polytechnic. So then I can apply as a co-investigator.
Yeah, I will
So I can be a co-PI
I'm
on that.
asking
Otherwise, it's just
that's what I guess we're thinking that.
Is that what you're doing next year?
No, I'm still at Harvard. While I'm at Harvard, he got his appointment.
So next year still.
Or at least this September, yeah.
Yeah, year after that.
I'm gonna apply for like a couple of jobs this fall, and then I'll apply for the year after.
Recently, I've also just been more
I like postdoc a lot. I like postdoc a lot. Oh yeah, for sure. I mean, because, well, I guess I have an unusual postdoc, but I mean, I can actually do a lot of the things that I want, like do research, apply for grants. So,
Were you not?
Oh, okay.
To link up to decorative, you have to go from this or maybe similar together, or does this topic become something?
Oh, is this like missile tracking where you see a bunch of people and you're not sure which group is which?
Well, this thing like dynamic topic. I mean, where you see a bunch of documents, you think there's some trend in the technology.
Oh, but this patient.
yeah, thanks for joining. I'll be really curious to get your thoughts on this work and see if there's any overlap that we might collaborate on. So
How was it when you spoke to Avi? Because Avi
it was great, yeah.
would have given you like a good
Sense, yeah.
sense of what you're doing.
If someone does a survey.
It was great. I think there were several areas of overlap with there's this universe idea where they add in
And
these
there's so much
These
more.
modules.
personalizations.
Exactly. And then also we were talking about some things in assessments or that he wants to run where we could kind of do some reinforcement learning.
Okay,
Yeah.
you're into reinforcement.
The lusty thing is now I'm very interested in experimentation and personalization. And so what I'll actually talk about today is how we can use reinforcement learning, more actually contextual bandits right now, just being really simple, like multi-arm bandits to do both.
Because they're different
Yeah.
people. But I've been
Would you
thinking about how you do that when
It's a bit flexible, so they're going to get lunch and chat a bit, and then I think
Because
12:30 to
now-
12:45.
the effect of the action might cause you to become.
And you, of course, you know everyone here, yes.
Not really.
Okay.
No final.
It doesn't.
Not
The action would be something.
Some treatment. That part's a lot more fuzzy to me. Like, how is it possible to do this at all from classification data? Maybe not. I'm not sure. Because patients are similar to each other, you know, like you have patients with similar characteristics and one slightly older or something like that. You can say, oh, maybe this person is the older person. You can put some smoothness patterns. Every action should represent like branch points. You know, like these people stay the same until they can, but it's a different action. Or maybe you have to make that assumption. I guess flip it around. Like if you don't make that assumption, is it impossible? It might not be possible.
Yeah, or unless you think that actually doesn't have meat, like, you know, they can't completely change something else.
Like they introduce some sort of variance.
I mean, I guess the actions can just scramble everyone's health entirely. And obviously, you don't have anything. But maybe if you say actions can only have small effects.
But how do you know, like, which, like, let's say, like, which is the person that followed taking this action? Like, if you're thinking of taking action A or B, and there's a number of people who look kind of similar to that teacher, how do you decide which one of those people? Like, it seems like the information that took this action can't really help you, because none of those people, you don't know what they did. Unless you just happen to learn that if you look even more time steps ahead, that there seems to be kind of a couple different trajectories, and now you can link them back to the other. So it seems like there's a set of actions here that maybe you need extended actions. Maybe you need to say like a treatment lasts a long time. Like an action, because then you can link people together. There's kind of what's on my mind.
Yeah, I guess probably there's like a lot of different ways to make things identifiable again. Like all sorts of
Yeah, some sort of assumption. Right, you need to make some sort of assumption.
Thanks, Brad, for you guys. Yeah, I think. Yeah.
So how long are you here for again?
Tuesday's my last.
Oh gosh, that's a pity. All right. Well, I'd love to. I guess thanks for coming.
This is the best.
Yeah, I'm guessing you're pretty busy before then. But if you have 10, 15 minutes, let me know. I'll make sure I'll be around. We can chat.
It's been very interesting stuff.
Okay, thanks. Yeah, I would love to have an excuse to come and visit sometime.
In Israel?
Oh yeah, for sure. Yeah, they need to have a conference there. One of my friends, he did his summer internship in Israel, and he really enjoyed it. And I knew that your lab did some relevant things, but only after speaking to Avi did I realize how close it overlaps. You know, the reinforcement learning, the HCI plus AI. You know.
It's not just it doesn't have the same like decade in. So, whereas in San Francisco, it just goes on and on with like multiple different places and you know, in-house like barista. It's like crazy.
They say you down there.
Yeah, I've been there 3 or 4 times, but
It's a much.
I'm hoping that was
Are there any interesting that you're supposed to hear getting to network on that? Are there any particularly interesting books that you're getting to network? That's
where SS yeah, I mean, there's some like engineers and stuff that we work with that seem really good.
I guess I feel like there's like, you know, SF is the home of these like larger than life personalities that, you know, you might get to hang out with. People have like bizarre like post-human lifestyles or like
What's that?
people have like bizarre like post-human lifestyles and like
I haven't encountered too much of this at Twitter.
Kind of seems like it's. Is anyone doing any ethical experiments like live testing their entire life? I don't know.
No, I mean, that's what, Twitter is all about, like microflowing every single thing you do, right? So there's some of that, but. So, yeah, culturally, I think it's probably a little bit less crazy than like, I think Google, for example, attracts some like pretty crazy people. I don't think Twitter does quite as much. Like Twitter has Twitter has a more pop culturally focused sort of culture than in Google. Google's kind of research centered where like, whereas, at Twitter HQ, there will be like celebrities coming through, like every day, famous athletes. That's kind of just a different vibe.
Yes, I see how it got exploded on the August. No, really know what to say about it. But it seems like we got lots more stars on the shit.
Milan is super excited about it.
Yeah. He said he's reading code and everything.
Hi.
Am I bringing coffee? Yes.
Oh, maybe.
13 order coming from Denny.
Denny, not here.
Huh.
For this time. Oh, Bill. I mean, it's
Well, if I do, if my contact isn't
It's
clear.
probably going to be somewhere else. Probably isn't.
Yeah, I think.
Put it up for us?
Yeah,
Yeah, no,
yeah,
but maybe wherever it is.
Whose name is it? Whose name is it?
So,
Denny.
Denny.
That's 2:30 for 1. Oh, take like very fast. Okay. Very fast. Yeah.
Two different.
Right now, I'm just,
We do have the room survey.
right now, I'm not doing anything.
I believe so. I mean, we were on Meg's like,
Okay, we're on.
calendar. I haven't checked day by day. Is there something where you check
So this, yeah.
time for?
They changed the system.
Does someone, all I know is that we like, Meg sent out like an email, like, call.
Okay, if like, okay, then
But I haven't heard anything like, specific about.
might check with Michaela, because they changed the system, and so it was the
So,
site,
what's the
website.
My name is Drew.
You.
Yeah, like,
Okay.
but anybody knows who you are.
So is
But
this
you
something that you
can
have
say
to
this
check,
is
or does
they
it,
come by.
eventually have to pull it?
Oh, that's it.
Okay, you have to pull it,
Well,
okay.
maybe we'll collide and but okay.
Thank you, man.
Did
You want to go ahead?
get
Sure.
started? Yeah.
Yeah. So one thing is I think I'm actually gonna do a lot of the writing on the board, which I haven't done in a while, and I'm not sure how far people see away. But I just have some slides from a more general talk, even ICML, that I can use to show as well. But just, I'm not sure how many of you already. I guess I know most of you, but in terms of what I'm doing, I'm a research fellow at HarvardX, which is Harvard's online education group. And I also work pretty closely with a lot of other online education platforms. And so I'm a human-computer interaction researcher. And my focus is on how do we design technologies, web technologies like websites, online courses, mobile health apps, so that we can actually do experiments in them to figure out what's working, like trying to optimize some user variable, like how much people are learning or whether they come back to use Facebook, by trying out different versions of a design, different websites, different messages, different prompts, and discovering, if we A/B test these versions, which ones work well on average, and then which ones work well for different people. So the idea is kind of mixing A/B testing or experimentation with personalization. Because if you think about it, anytime you take a technology and you make two versions of a website, you can see what works well on average, but you can also see what works well for which subgroups. And the really nice feature about technology, which is just not true in the real world, is as soon as you discover that something's working well for one subgroup, like low knowledge people, you can immediately start personalizing using a policy. So that's the general approach I take. And so through that, my PhD was in cognitive science. So I did my PhD with Tom Griffiths and Tanya Lombroso. So I focused on experimental psychology and learning, but also using computational, like Bayesian machine learning to model different aspects of reasoning. And now I'm actually kind of moved more towards HCI and applying machine learning. So that's kind of the context where I'm from. And so one thing I should say is that what I'm kind of presenting here is pretty informal, but especially it's not that I have a specific algorithm set of results, but I'm actually working through that now. And so I'm actually more presenting a problem and very curious to see what people think and have feedback on. You know, what are ways to solve this problem, even things you can give me suggestions and how to frame it when I present to other computer scientists. So it has a very nice, one thing I should mention, I'm originally from Trinidad, and I'm telling you that because people say they miss part of what I'm saying because they're trying to guess where I'm from. So the mystery is solved, but also it means that I speak way too fast, and then my accent makes it sound like I'm speaking twice as fast. You're basically hearing accelerated up to 4 times normal speed. So basically, you know, it has this very broad kind of topic, which is, you know, if you think about it, with web technologies, every piece of the digital technology is malleable in a way the real world isn't. You know, as soon as you think something or have an idea of how you want to A/B test or deliver content, you can do it by implementing algorithms. But actually, it would be really nice if things like machine learning algorithms were actually implemented in more of these web technologies. So in Harvard X and their online courses, in Facebook, in Google, they certainly are big on machine learning, but how often is it that you've actually got algorithms that are operating in real time? Like, for example, multi-arm bandits, it's a great set of work, but actual applications can be a lot harder. You know, even in MSR at ICML at lunch, they were complaining that they can't get a lot of the people who do A/B testing to actually use the algorithms in real time for all kinds of reasons: engineering, practical, conceptual. But it would be really, what I think is what I'm aiming towards, or kind of work that I'm interested in, is basically if we could take a web technology and embed machine learning algorithms into it. So you have a website where there's reinforcement learning algorithms operating on it. So as data is coming in, it's constantly testing out and changing things. So that's the ideal vision. And in particular, I think the web technology space is especially interesting. So I think it's especially interesting because what we're trying to do is maximize functions of users or people. So just to give you a sense, there are many different things you could optimize. We're going to optimize whether someone responds to an email, whether they buy a product. But also it's a case where we've actually got a huge number of underlying latent variables. So we're basically trying to optimize or improve what's going on. But a lot of the variables are a human being under the surface. So we have to infer them. And one thing I think I'm going to mention is a really powerful feature of this environment is often we might put up a website or we might put up an online course and have different lessons. And we actually don't know yet what our reward function is. What are we trying to optimize? We can make a guess. We want to optimize what they learn tomorrow. But 3 weeks later, that's going to change because we realize maximizing what they learn tomorrow, it was kind of right, but actually we should have been maximizing what they learn next week. Another feature is the data we have is also constantly changing. And changing in the sense that I might be running an algorithm on students in the first week of a Harvard X course. And at that time, all I've got is basically what they said on the pre-course survey. And then a week later, now I've actually got additional data from edX that's saying, well, actually, this person's from this country. This is how many courses they've done before. So essentially, if I had a policy saying, well, you know, I was randomly assigning lessons 1, 2, 3, or 4, I probably made some assumptions about reward and about context. So I tried to optimize based on what seems to be working. But then all of a sudden, I've got new data. So now how do I actually, it's pretty easy to go back and compute the values again with this new data. But how do I use policies that from the time they rolled out are expecting that 100 subjects later, 1,000 later, I'm actually going to try to optimize a different reward function. I'm actually going to do it using a different set of context information. That's the kind of problem I'm thinking about. Okay, so as I kind of mentioned, that's kind of broad kind of problem. Oops, sorry. Yeah, so as I mentioned, that's the kind of broad problem being tackled is how to embed machine learning user technologies to do experimentation, personalization. And just to flag one thing, Finale is a co-organizer on a workshop on interactive machine learning, which basically is thinking about this topic. So I'll send an email out to that, but if people have suggestions of who would be good participants or how to message this to the broader community, that'd be really welcome. So I think I'm just going to give a brief foreshadowing of an example of a study I've run, which is what I'm trying to model right now, and also how I'm currently formulating that problem. I'm just going to try and do it in 5 minutes just to get you thinking. And then I think I'm going to talk about the kind of one big key idea of contribution of this work, which is basically an abstraction that allows someone who's doing machine learning and someone who's to interface with someone who's building railroad technologies. So it's essentially an abstraction that allows you to take any A/B testing framework and convert it into something that lets you roll out a policy for reinforcement learning or bandits and actually have that policy change dynamically. So that's one kind of a key high-level idea. I'm going to try and go through that quickly in about 10 minutes. But then the specific problem is what I'm going to reduce to. So I'll briefly foreshadow it, then I'll talk about the high-level idea of an abstraction that anyone can use, or if you want it right now to roll out a particular multi-arm bandit algorithm in edX courses or somewhere else like that I work with, you could actually do this in real time. And this is what I've been playing around already. But then the specific problem that I'm now trying to tackle is something like if I'm trying to maximize email response rate, get people to respond to emails with 3 different experimental variables and only about 5 or 10 user variables. What kind of policy should I be using to do that? If I expect that as I'm sampling and experimenting, I'm actually going to be changing my reward function and I'm getting new contextual information. So that's a kind of specific problem. And I'll just talk a bit about some first steps towards an algorithm, or at least the properties that I think an algorithm for doing this should have. And so this is where it'll be great to get. Any questions or finally, any suggestions about allocation of time?
Well, I think this is before people are probably going to be most interested in a specific problem.
Okay, good. Okay, so I can jump that. Then maybe, okay, so maybe actually what I'll do is instead of foreshadowing high level, let me actually just do the high level in like 5 minutes, and then I will jump into the specific problem. And finally, just because we've talked about this a bunch before, please feel free to step in and make a suggestion or clarify something someone else might not. And Kobe, you're welcome to as well. Okay, so basically, there's this formalism that I find of a MOOClet, which is something that Facebook or Google or online courses can basically use to take the A/B test framework and turn it into something that lets you do real-time policies for RL. So basically, the problem is a typical technology like this online course, what can you change in this? What data is available? It's really hard to say. The kind of key idea of a formalism like the MOOClet, which I developed, is saying, well, let's take a component of this, like that paragraph test, and turn it into a MOOClet. So there's a process for doing this. And it's actually pretty straightforward engineering-wise. Because it basically says, well, you want to be able to make multiple versions of that and A/B test them, of course. But actually, instead of doing A/B testing by just saying, well, we hit there, let's just choose one of these randomly. It says, actually, here's what to do. Why don't you implement your A/B testing? Actually, let me see a better slide for that. Let me just define it. Okay, so basically, what a MOOClet consists of is some component of technology like this that you can make multiple versions of, and that you can assign them either randomly, so you're doing an A/B test, or you can assign them based on some feature of a user, like the knowledge or what they said yesterday. So that's basically what a MOOClet allows you to do. And so what that means is that you kind of basically get for every MOOClet, you can almost imagine, if I say I've got a MOOClet, which is this exercise in a Harvard X course, you could say, well, tell me what the versions are. So I can tell you basically how many actions you can take. And then you can say, well, tell me what data you have about users. And so I give you a list of variables like their pre-test score, their level of motivation. And then you can say, tell me what policy has been used to assign people to MOOClet so far. And I might tell you it was random, it was slightly biased, and so on. And then you say, you actually can do through an API call, here's a policy I'd like you to try. And so you actually send that back in real time. And so as subjects show up, they're being assigned using your policy. And then that data comes back to you in real time into the user variable store. And so you can actually run an algorithm like a multi-arm bandit or any kind of reinforcement learning algorithm in real time.
What is V1 and V2?
V1 and V2 are the versions. So the idea here is that just the language I use is like a MOOClet has different versions. So for example, there are 2 different paragraphs of text.
So you manipulate which paragraph you want to show.
Exactly. And so that's in the AP test. The version is like condition 1 or condition 2. In reinforcement learning, version is action 1, version 2 is action 2. And so what that means is basically then reinforcement learning, you have a set of states, a state space, actions, and a reward function. Well, the state space here is just combinations of user characteristics. It's like a vector of features about users, like their knowledge, what they said on the last problem you showed them, their gender, and so on. The action space is actually the alternative Mooklet versions that can be delivered. And the reward function is going to be something that lists the variables about a user that either you or the instructor, the person you're working with, wants to optimize. For example, learning on the final exam, or maybe it's more short-term, like how they do on the assessment immediately following the different paragraphs of text they just saw. And so what I think is kind of nice, and of course the policy are basically which of these Mooklet, it's basically a set of if-then rules, at least it would be expressed that way to the person delivering it to, for saying which Mooklet version should you give based on someone's characteristics and how much randomness should there be in that. To what extent should you be experimenting versus just straight out giving people what it seems like is the most helpful. And so I think what's useful about this is that if you were to walk to Google or edX or anyone else and say, I'd like to do reinforcement learning right now on your platform. I mean, first of all, they might not necessarily know what you mean, but it's not clear at all what can you change and how do you go from A/B testing to actually something like a full-out policy. Because what you actually will basically see is that in most platforms, they've actually got, they implement A/B testing in a way that actually is actually really unfortunate. If someone's building A/B testing framework right now, I would say, just stop what you're doing and please just use this simple design pattern from the Mooklet and everything will be good. Here's why. And this is actually, to me, a big insight, and I was doing experiments for years. If I'm going to implement A/B testing, well, what I say is, here's how most platforms do it right now. Here's how edX does it. For example, when you hit this thing, which is like the paragraph of text in Mooklet, when you hit that node, let's just choose one of these and give it to you randomly. Randomly meaning 33% version 1, 33 version 2, 33 version 3. That's a totally natural way to do it, right? Why would you do anything else? Well, actually, that's only one kind of policy. If you made a simple change, which is to say, actually, instead of doing that, which is done everywhere, let's just actually say, when you hit that node, why don't you then set a condition value, A, B, or C, using a weight? So just say 20% of people get condition value A, 50 get B, and 30 get C. And then let's go and look up that value of that variable and say, okay, I'm going to present the Mooklet version based on that. So all of a sudden now, that actually lets you do that multi-arm bandits, dynamic policy change. Because you can do A/B testing, you just set those values to be 30% across the board. But as you get data, all you do is you go in and you don't even change code, you just change it from 33% to 40, to 50. So it's a kind of simple change, but it's not what most people implementing actually think about. And it's very hard to do after the fact. You want to do it at the beginning. Well, here's actually one where you can take it even another step up. What if instead of saying, I'm going to assign people 40%, 20%, 20%, I said, let's actually just set a value of a variable. Sorry, I kind of actually did mention this. Let's actually do experimentation by saying, let's define what percentage of people are going to have a value of conditions set to A, and what percentage to B, and what percentage to C. What that means then is that you could actually then go and swap that variable out. You could start off saying, well, I'm going to assign a variable randomly, condition A, 40% again, 40% get condition value A, 40% have it set to B, and 20% to C. But you could actually then turn around and say, well, experimentation and personalization are really formally equivalent. They're just two sides of the same coin. When I do an experiment, I'm presenting based on a variable that was set randomly. When I'm personalizing, I'm doing it based on a variable that was set using user characteristic. And so in fact, if you actually implement the way Mooklet specifies to it, is you could then say, well, I'm going to start off experimenting where I just set variable values with weights. But then actually, after some amount of time, I can actually just replace those variables and say, well, if the pretest is less than 50%, let's put 80% in condition A and 10% in B. If the pretest was greater than 50%, pretest here is some measure of people's knowledge. Then if the pretest was greater than 50%, let's actually just change what proportion of people go in each condition. And so the idea here is that we're thinking about experimentation personalization in a continuous way. What it means to actually personalize is just that the proportion of people getting different conditions is being changed. So I think this way of thinking about it is not typical in how a lot of people, even psychologists, do experiments. But it really does provide a nice way of bridging experimentation personalization. And I think the really key thing is that simple change from how it's hard-coded, where you hit a node and give them equal probability, to setting variable values and then delivering it based on the value of those variables, that basically means that anything that has a setup can take a reinforcement learning policy. So what that means is that anything that, instead of doing A/B testing this way, just do it that way, and actually you're guaranteed that you can run these policies in real time. And that's what I've basically set up now in edX courses that I work with, and also there's another platform called Assessments, which has math exercises. So that's the kind of high-level idea. So now that we have this ability to sort of take a technology and make it able to take these reinforcement learning policies in real time, well, what do we do with that? What's the kind of value? And so this is now that was the high-level kind of idea and the contribution of nuclear design patterns. So here's an example of a concrete problem, a study that I've done, and the specific problems that I'm trying to solve and attacking it. So here's one way in which it uses Mooklet. So basically, I had an instructor come to me and say, I'm sending out emails to people and I'd like them to respond more frequently. That's my goal. So they essentially have an implicit reward function. How do I increase response rate to these emails? Well, I said, okay, let me define your email as a Mooklet, which means that I'm going to take these different versions and I'm going to start off randomizing, but then I'm actually going to change the policy over time. I did a really simple dumb policy change, but this is just illustrative. So the reward function in this case is going to be the responses, whether or not they respond to a survey. So the instructor sends its emails out to about 4,000 people, and every time someone responds to a survey, we're like, okay, reward of 1. If they don't respond within 2 weeks, reward of 0. The state space and context vector here is super simple. It's actually just 2 variables. It's the 2 categorical variables. The age group, 18 to 22, 23 to 26, and so on, and the number of days active. And I could talk later about why I did them as categorical variables versus continuous. The action space is different versions of email. And this is where I think it's valuable this was done as a Mooklet, because trying to change a piece of real-world technology can actually be complicated. In the other hand, when you define that the subject line of an email is a Mooklet, the text, it's actually really easy to just keep on adding actions. So here we actually just generated 3 different experimental variables. We changed the subject line of the email, had 3 versions. The body of the email had 3 versions, and the link that people click to respond had 3 different versions as well. And so just to start you thinking now about how this connects now to a machine learning problem, well, I'm going to start off doing randomized experimentation. But then I can actually do some kind of hybrid where I'm trading off just straight out dumb exploration with actually some kind of personalization. Where, well, actually, I should say, first of all, there's just what condition is working well, which email is working best. You want to give it to more people.
I understand the condition of this problem. Is it the same users receiving?
No. Yes. So it's brand new users, exactly.
Then how is the environment responding to your actions in a way that you can model as a reinforcement learning?
Yeah. So thanks for the clarification question. I'm going to think about just contextual bandit problems, which are basically where there's a fixed context vector.
It's a bandit.
Yes.
Modeling it as a bandit problem.
Exactly. At least this specific case, yes. There are other studies that I'm doing now where what you said is much more appropriate. Like, yeah, in another study where every week we give people a different hint. So the same user for an entire course will get randomized versions of hints, and that's something where it's much more of an interesting reinforcement learning problem. Where I'm just talking about the special, simple case of a bandit.
So there's an implicit reward function you're trying to learn?
No, actually the reward function is specified. I'm actually just trying to learn a plain dumb bandit.
Okay, but bandit problems learn reward functions. So you're assuming that the true reward function is the response of the
oh yeah, sorry. You mean they learn the distribution of the reward?
and
Yes,
and every time you get an email, you get back a noisy estimate.
exactly.
Of how many of what of whether.
No, every time you get an email, you get to know the reward, whether they responded or not. And I mean, just because thanks for raising it, Kobe. I guess just to, I mean, is everyone here? If you're totally remember, you could write down the formal specification of bandit right now. Could you put your left hand if you could do that? No? Okay, right if you can't, write down formal specification. Okay, good. Okay, that's good to know. I didn't know that.
No, you don't have to specify the bandit problem. You just think I'm trying to map.
Yeah, but it's actually really,
what you're trying
it's exactly the next thing I want to go into. So the basic idea is like, the multi-arm bandit is basically saying, well, you have a set of actions. So in this space, the action is going to be, let's say A1 is, we sent an email to a user with subject line version 1. It says something like, fill out a survey. A2 was basically the subject line that said, are you returning to the course? And A3 was a subject line that says, give us feedback. So just to make it totally concrete, this is the kind of problem that I'm trying to model now. And what happened was we'd send emails to students, and the instructor says, I'd like to increase how many students actually fill out this email, actually respond to this email with useful feedback for me. And so we said, okay, I'm going to make different versions of email. I'm going to test out which subject line is going to be most effective at getting them to respond. And so the 3 different actions were fill out a survey, are you returning to the course, like a question, meant to kind of entice them, and then finally, give us feedback. And so that's the basic action space in multi-arm bandit, but then also multi-arm bandit has a definition of reward. So the idea is that the way the multi-arm bandit will work is that you take these actions, and at the beginning you know nothing at all, and every time you take an action, you get an estimate of reward. And then based on that, you can start to estimate which actions are giving you the most reward. And so in this case, the reward is basically going to be 0 or 1. And it's going to be 1 if the student responds within 2 weeks of the email. So you actually, great. I sent the email, they actually responded. And it's going to be 0 otherwise, if they don't respond after 2 weeks. And so the kind of question here now is, for the instructor, which of these email subject lines is most useful? Which one is actually going to get people to respond? And so there are a lot of algorithms, so things like multi-arm bandits, upper confidence bound estimates. But the simple dumbest principle you can keep in mind is how do you trade off exploration and exploitation, where you might just pull each arm. If you were doing a randomized experiment for the first 30 people, you would just put 10 people in each arm, right? You just pull them without any preference. Then you stop and estimate, well, what's my estimate of the parameter for arm 1? If I send subject line 1, is it that 0.05% people responding? What about line, arm 2, is it that 15% people responding? The idea is then you formulate some estimates of these parameters, and then some estimates of the variance around them. And so now, given that problem, how do you actually trade off whether this one seems to be best, you got like 15% response rate here, and this is only 10 and 5%. Well, should you just maximize and do that all the time? Or is that actually risky? Because maybe there's so much variance that you should explore these because it might actually be better.
So I'm just not sure, but it's not just about like vision optimization, but just where you have an extra couple of variables like this age and number of days where you can vision on them. And I mean, could you just adapt the whole vision optimization framework to this case? And then you wouldn't even have to like discretize the age, for instance.
So I actually would turn to you guys as the experts and say, what do you think? Yeah, I'm sure I suspect you could, because Miguel, I think you've told me they use it for A/B testing and so on.
Basic optimization and contextual bandits are basically the same thing. So basic optimization you could look at as a bandit problem with simple regret, right? So often these problems have have something more like cumulative regret that you care about, right? Where you don't want to do really dumb things to somebody along the way to a good solution, right? You care about every single every single step. You want them to have a good experience, right? Whereas Bayesian optimization, as long as your final result is good, you don't care how dumb it was in the meantime. And so, but these are actually just kind of like, these are the same kind of things, just on the spectrum of, they're just kind of 2 points on the spectrum of ways you might consider performing, solving a contextual bandit type problem. And so then, for example, like, folks like Andreas Krauss, right? Like, view Gaussian process Bayesian optimization as exactly a special case of Gaussian process bandits. And the UCB type framework stuff they've applied, the GP UCB framework was just a particular acquisition function for solving all these problems with Gaussian processes, where that's what's mapping from like this context space into the or it's like an infinitely armed bandit basically.
So in bandits, it's called contextual bandits, and you have these extra variables.
Covariance.
And in Bayesian optimization, is there a word for that? Have this context?
accessible.
That's your excuse.
Well, no, so it's differentiating between the actions you're taking. So a GP is a little bit funny, right? Because so the multitask type Bayesian optimization is actually kind of like closest to that, right? So the task is like the context now, and then you have an infinite set of arms that have these features attached to them.
So picking up on what Ryan said, sounds like you want to be very careful not to email students if you're not sure that the subject and parameter settings for those students are optimal, right? So you're trying to avoid that.
Well, I guess the thing about that,
Zeros one is confusing.
sure, okay,
You can access each student just once or several.
yes, exactly,
Just once.
just once, exactly.
So then shouldn't the reward function simply be the number of students who reply to the mail?
Yes, yes, sure. I mean,
And you want
if it's
maximize that.
well, it depends how you define it. If it's a Bernoulli bandit, then the reward function is 0, 1, but you're absolutely right what we're trying to figure out. And yeah, sorry, not the proportion number, yes, that's what we're trying to optimize in the long term, yeah. It's the total number of students who respond to the email, yes. And Joy, just one thing I should be a little different. I actually don't know, I know next to nothing about Bayesian optimization, so sorry, I should be a lot more familiar with it, but it's not an area that I've worked in, so I'm actually really happy. If something I'm doing here, I get too much about Bayesian optimization, I'm totally happy to actually switch over and go and see what I can learn about using it. I'm just explaining the vocabulary that I've been looking at this in so far.
So I mean, from your point of
Yes.
view, you can think of Bayesian optimization as exactly like a Gaussian process, and it's like almost exactly the same thing with simple regret instead of cumulative regret.
Okay,
And that would like summarize. It's like close enough to the truth. That,
oh, great, okay, thanks. Okay, so I think responding to Kobe's question, yes, in a multi-amp band formation problem, what I want to optimize is just how many students I get to respond over in the long run. If I send out 4,000 emails, how do I maximize the number of students respond? That's exactly
And
right.
you want to minimize the amount of emails you send.
No, that's actually not a consideration. So in this, you could very well have that, but in this particular problem, the instructors are sending these emails no matter what. They're going to send them to every student in the class. So basically, the instructor just saying, I was going to do this anyway. Can you help me actually come up with some new actions? And I did that. Then they say, as a psychological researcher, I did that. I came up with new actions. As a machine learning researcher, the instructor says to me, can you actually help me have a good policy for experimentation? Because the psychologist would actually give everyone equal numbers. They would never do anything else because they're just interested in learning what works. The instructor might do something that looks a bit okay, but actually could be wrong, which is after the first 100 students now start giving everyone action 3. So in a multi-banded formulation, the idea would be, make estimates of what these parameters are, a portion of people who respond to subject line 1 versus 2 versus 3, and then on each time step, have a way of choosing arms. So for example, upper confidence bound algorithms basically have an estimate of the proportion of people who respond to each of these, and then they have a way of computing an upper confidence bound that you add to that, which varies based on, which depends on how much variance you've observed in that arm. And they simply say, at this time step, I'm going to choose the action with the greater upper confidence bound. The Thompson sampling, which is actually something I'm going to explore in more depth because it's kind of related to what I'm doing, basically says, I want to estimate the probability that arm 1 is the best arm. So for example, if you see that there's a 5%, so I did this for 100 observations, 100 students, and I see there's a 5% response rate for action 1. And there's a 10% for action 2. And there's a 15 for action 3. The totally greedy thing to do would be to just choose this. And you could do epsilon greedy, where you just choose all the time, but every now and then you explore. What Thompson sampling would say is, I want an estimate based on the proportions I've observed and now the number of subjects. Let's say I did like 33 in this, 33 in this, 33 in this. I want to now have an estimate that on my next trial, after these 100 subjects, for subject 101, what's the probability that action 1 is the best arm? And you can see that probability is pretty low because it's not a lower percentage and you have a reasonable amount of data. What's the probability action 2 is the best arm? What's probably action 3 is the best arm? And so Thompson sampling would be saying, compute those probabilities and then don't just choose the one that has the highest probability. sample actions according to that probability. So I guess I should probably write it out.
So constant sampling is basically where you have a regular constant sampling. Like you draw a sample from the posterior distribution of possible true states, and then you assume that that state is the truth, then you take the maximum of that. So you're greedy within a posterior sample.
I think what maybe what I'll do is let me just finish the details and then I won't do the slides anymore. But so basically here's the study just so it's concrete. You basically have 3 experimental variables that are totally independent of each other. Every student gets an email and there's a subject line in the email. And it could be like, are you returning to the course? Fill out a survey, give us feedback. There's an intro message, which is something like, we hope you've enjoyed it, give us feedback. Or, it's really helpful. That's one version. A second version could be, you really make a big difference to the course when you help other students, give us feedback. And a third version might just be, give us feedback. So the idea is that these are all different candidates that a priori the instructor, me, other people thought were reasonable, and we're just experimenting with them. And finally, the last variable was basically how they responded. So they could either respond by having a link, like click here to fill out the survey, or we actually just had them say, click this link if you think the course was great. Click this link if you think the course was bad. So that's just a different response format. And the third response format was where they didn't even have to go anywhere else. We just actually put all the questions in the survey inside of the email directly, so they just clicked on it and made the response. So you don't necessarily care about those details, but I have the sense that making it grounded just helps for everyone to think about it. So basically, in this formulation, we have 3 experimental variables, and you could treat these either as 3 separate multi-arm bandits, or you could cross the factors and have one bandit with 27 conditions. But the key idea is that there are 3 different subject lines, and we assign that randomly. So we get a student, and we just choose one of those randomly and give it.
What's the population of students?
The population of students is in an online Harvard X MOOC on public health.
So it's one course?
One course, exactly.
How many students?
The total course had about 10,000 students.
And are you sending the emails at the end of the course?
No, we're sending them in between the course, like after about a couple of weeks when we have a sense of whether they're engaging or not.
So implicitly, bandits assume some stationary distribution of the process that's generated.
Which may not apply in this case.
Which obviously is not the case in the MOOC.
Exactly, yes. And that's totally true. For this case, at least for the problem that I want to solve, I think at least the problem I want to solve, whether it holds or not, we can assume that the distribution is stationary. Okay. So is everyone kind of clear on that design there? So we get a student, we look at the subject line, we choose that randomly. Then we get another student, we look at the intro message, we choose that randomly, and then we choose the way they respond randomly. So it's totally separate assignment. It's in psychology, it's called a factorial design, because you've got 3 different experimental variables, each with 3 values, and these are independent. So for example, you could treat this as like 3 separate multi-arm bandits where you just want to optimize the subject line. What's the best thing to do? Or you could actually also have done this and had one multi-arm bandit with 27 different arms, where you say, well, subject line version 1, the one arm is choose subject line version 1 and choose intro message 1, choose response format 1. The other arm is choose subject line version 1 again, but now choose intro message 2 and choose response format 1. And then you do it again and again where you basically have 27 values from the 3 by 3 by 3. And the way we get the reward, as I mentioned, is whether they click on that link and actually give us feedback on the survey. So I mean, the main point of that was just to provide like the concrete context we're thinking about. Do you have any recommendations for what I should talk more or less about or focus on?
Whatever you want feedback on. Maybe another
Okay.
20 minutes or something.
Right. Would you mind tuning that off? Right, so then the way you might form this problem is to say, let's assume that for each of these arms, and let's just talk about subject line, let's say. So we just have 3 different actions. Let's just assume that we have some uniform distribution over each of these arms before we see anything. So for example, you could assume there's a basic distribution with, it could either be uniform, let's say, Or you might actually choose the parameters based on some knowledge you have, whether response rate is high or low. And then if you're doing Thompson sampling, the way it would work would be that you would actually say, okay, I've got some prior distribution on what the proportion of people responding is, right? Right now, let's say it's uniform. Then you make some observations, let's say from these 100 people. So now you've actually got some data information, and you can actually just, since the beta is conjugate to the Bernoulli, you could actually then just update your beta distribution. And in the simplest case, it would basically be, let's say if you have a 5% response rate, well, then you basically just have 1 plus the number of successes is 5. And I think if I'm just remembering it right, 95, right? So basically, if you're using Thompson sampling on this simple multi-arm balanced setting, what you're basically doing is that every step you're just updating the beta distribution over what the proportion of people who's going to respond is. And then to do Thompson sampling here, what you're then going to say is, well, given the distribution I have, which is based on what I've seen, but also the variance I expect, let's compute the probability that this arm is going to give me let's compute the probability that that is the best arm so far. So essentially what you're doing is saying, well, I have a beta distribution of the parameters for each arm, and you could be greedy and just choose the one with the highest mean, but instead you're saying, let's just compute the probability that arm A is best, based on that proportion, and the expected variance, arm B and arm C. Let's pretend those probabilities were something like, in this case, about, whatever, 0.02, 0.5, and 0.3, and then
Joseph, can I interrupt? I'm still
For sure.
unsure a little bit about your design. So you have 10,000 students.
Yes.
Right? That's your sample space.
Yes.
And then, like you said, you have a factorial design for the experiment. There are
Yes.
27 configurations
Yes.
for emails.
That's right.
So are you then taking these 10,000 students and dividing them into pools? Since you don't want the same student to receive more than one mail,
Yeah.
you're constrained by...
Well, it's a sequential assignment. So we have the 10,000 students, and we say, okay, we're going to email student 1. Which subject line do we choose? So I'm actually just treating this simple
And
case.
then you wait for that student to respond.
In an ideal situation, yes. That's not actually what we do. We send actually emails to about 500 people, then compute, then we send another 500.
Randomly sampled from those 10,000.
Exactly, yes, that's right. Okay. Okay, so then what Thompson sampling would do would be basically say, well, let's just choose, every time I have a student, I'm going to put 2% of people in arm 1, 30% of people in arm 2, and then 68% of people in arm 3. So that's the basic idea of Thompson sampling. What's nice about this is that it's basically, it does have some reasonable guarantees about what we converge to the optimal solution. It's really easy to implement. But I think one of the best things about it is that it has a very interpretable, it has a very good interpretation. It's basically saying, let's assign people in proportion to probability that's a good condition. Now, I actually, I'm going to now just say what a different approach is and what we actually use in this context. Are you ready? What we actually did was to say, actually, I'm going to say the simplest version of what we did, which is very heuristic. It said basically, well, I like this idea of assigning people in proportion to how likely that is to the best condition. What if we actually just assign people not just in proportion to how likely it is, but actually how likely it is, plus also how good that condition is relative to others. So the idea would be really heuristic. This is the most heuristic version. There's more reasonable ones. But why don't we actually just take our estimate of the proportion of people who respond and just divide it by the estimates of the others? So it's basically saying, sort of like it's a softmax policy where we're saying the probability of selecting a condition is just in proportion to taking the likelihood of someone responding as the value function. Where we're just going to say, well, how likely is someone to respond in that condition relative to the others? Okay. Any questions about that? So the idea is the same way you just get 0.05
divided by these, you would just have 0.10 divided by the others, and 0.15 divided by the others. And to make that concrete, yeah, okay, you guys can kind of guess what it's about. Now, this is different from Thompson sampling, I think, in an important way, and this is where I'm trying to formalize and see how it's more reasonable. Thompson sampling says that you start to give people things more often if there's evidence that it's the best condition. What this also says is actually that you start to give people something more often in proportion to how much better that action is than others. So it actually incorporates some element of magnitude. So to give a concrete example, here's what I think is kind of wrong with something like Thompson sampling under settings. Let's say that the true weights were something like 0.08. I should just make it simple. Let's say 0.08 and 0.07. All right? Now, what Thompson sampling will do is Thompson sampling would actually, even though that's such a small difference, it's going to converge towards giving everyone that, and relatively quickly. Now, why doesn't Thompson? Now, if you compare that to the case where it's 0.08 versus 0.04, right? Now, these cases are really different in the sense that Thompson sampling just says, find the best thing and give it to someone all the time. It doesn't matter so much whether the best thing is a little bit better or way better. The fact this is way better means that you get evidence more quickly, so you're going to converge. But here's kind of a problem with that, and for the kind of problems I care about. Let's say, as I kind of mentioned earlier on, that the contextual bounded formulation is actually not the right way, is not really the problem that we're solving. Here's the problem we're solving. We're going to start off experimenting. But when I reach 500, the instructor is going to say, actually, you know, Joseph, it was dumb of me to say that I wanted people to respond. I want people to respond to the email and actually say something useful. So basically what happens there is that I was optimizing multi-arm bandit for one reward function, which is just response rate. But actually I know, even before I start experimenting, the reward function is going to change over time. So for example, the reward function might not be just 1 or 0 based on whether they respond to the email. It might actually be when we analyze the data that they say something useful. Or maybe the reward function is actually whether they return to the course. Send the email, get them to come back to the course once. So here's the kind of problem with this approach. If you use Thompson sampling or other things, Thompson sampling is actually the one that is least egregious in doing this. Basically, they're going to say, they're going to hyper-optimize. They're going to give something as long as it's even just a tiny bit better. And what that means is that if I ran 1,000 people, by the end of that, you know, hardly anyone will be getting this condition. Maybe, you know, let's say 1% of people will be getting that versus 99% here. Now, what happens when I get information like the reward function has been changed is I could then actually go back and recompute for the samples what my policy should be under this new reward function. I can do that, that's pretty easy. But the problem is that I actually just don't have any data in that alternative condition. Whereas with something like this, it would have said, well, 0.08 over 0.05, it's going to actually be putting about, let's say, just make it up 55% versus 45%. Because it's going to be 0.08 over 0.15. Now, what's nice is that in this condition, of course, Thompson sampling might look a lot like that, but this condition, this kind of algorithm would be putting something like twice, you know, 66% of people here and 33% here. So I just said a very heuristic kind of algorithm, but there are more principled versions of this. But I think the key idea to capture here is how do we have a way of computing policies that takes into account not just what the best arm is likely to be, but actually the magnitude of the differences between arms. Because we know that we're not actually ever going to solve a bandit problem or contextual bandit problem. We know that the prompt formation is going to change. After 100, 500 subjects, we're going to change reward functions, and that may happen multiple times. We know that actually we may get, I didn't get into this, but we might get more contextual information. So I didn't get into contextual bandits at all, I guess based on time, but if I was optimizing before saying not just what's the best arm, but what's the best arm for which age group, I could have done optimization, but I would have ended up giving all the older people A1, all the young people A2. Suppose then I get another piece of information like whether someone's male or female. I just didn't have it before. Well, now because I was over-exploiting, I actually just don't have the data to go back and recompute my policy. So I actually now can go back and say, well, I have this new data, so I can go back to my original 1,000 people and just recompute, well, given this new context vector, what do I think is the optimal policy to do moving forward? And that's actually totally fine. All that data is now here. It's just like after the fact.
So I have a much more basic question for you. Have you raised an interesting approach to handling communication between course staff and students in a MOOC.
Yes.
This approach is to use this bandit
Yeah.
interpretation. And how well does it work? So for example, if I just compare it to what they did in the MOOC so far, I mean, maybe
How does it? Yeah.
does it actually find interesting clusters of users that need different policies? So for example, do females require less?
Yes.
Different.
Yeah,
they do.
exactly,
So you
yeah.
actually are able to show them.
Yes, and that's the data I didn't get to, but yeah, exactly. So, I mean, you raise a couple of points there, but just so you know, yeah, those contextual factors do matter.
They matter.
They do matter, yes.
And if I just try to optimize as a human, I'm not able to do as well as
That I haven't tested as yet. Because right now, and especially to this audience, I'm basically just talking about the machine learning aspect, but I mean, that's a great question that I'd like to pursue.
No, I think I'm still learning about them. I'm still talking about
Yeah.
the machine learning aspect.
Okay.
I think what you're saying here, beyond this focus on the sample process, is an interesting approach, a very different approach towards handling
Yes.
bandits. So
Yes, yeah, and that kind of, I think, gets some things that like interpretable machine learning, if I'm not misconstruing the talk of another gift. Yes.
I mean, it seems like there's kind of like a conceptual difficulty though in saying, oh, and my reward might change at some future time. And
Yes.
so, I mean, essentially in general, under all possible future rewards, you should sample either according to some like information criteria or essentially uniformly. There's kind of like a no free lunch problem here, right? Which is that anything I do, there could be some antagonistic future reward function that would be, for which this would be the optimally bad thing.
Yes.
And so in general, like, I mean, I don't know how you sort of like principally balance that without making strong assumptions over how the reward functions might evolve.
I agree with you that there's totally lacking anything I've said this before, some assumptions about how that reward function will change. I'm actually very open to thinking about those and suggestions for what I should think about, like, does reward vary smoothly? How much is it going to change? So I'm very open to that. I think what I would say is that I'm not thinking about the worst case scenario. For sure, you can always screw something over by changing the reward. I'm just saying, if integrating over all the possible ways reward could change, this has some nice properties. Which is to say, I'm trying to, you're right, okay, I mean, it has some nice properties given certain assumptions which I have to spell out. But I think the intuition here is that it seems to be, there's a good thing, and there's certain cases, and this is what I'm testing simulations now, where it's a good thing to say, I should trade off current reward against some future reward. You know, like if you want to make a very simple assumption, I'm going to say, after every 500 subjects, the reward function is going to change change in some specified way, but it's going to be correlated at the level of 0.8 with the old reward. Let's just say it says something like that. Under that kind of assumption, this would then trade off this algorithm that basically uses the size of the condition of the expected rewards would be better for that case than something like Thompson sampling or upper confidence bound, because these things would overexploit.
But it seems like there's almost no way you could potentially do better than a sort of epsilon Thompson sampling, where you're basically saying some fraction of the time I'm going to sample uniformly from the arms, and the rest of, and in the remainder of the time I'm going to do Thompson sampling.
Yes.
I don't know how you could kind of do better without stronger assumptions about.
Definitely, absolutely. Yeah, and so this is helpful because you're right. I am actually implicitly assuming that the reward will be correlated with the old reward.
Yeah, so if it's correlated, that's a totally different
Yeah,
thing,
that's
because
actually,
that's what you're talking about losses, right? And the losses are meaningless if you draw again from a
yeah, that's
completely-
absolutely true. Yes, yeah. So actually, yeah, thanks for that. I should have said that was one of my assumptions when I presented this. Reward will change, but it'll be correlated with the old reward. Yes. Yeah. So this, what I've done here, is totally heuristic and random, right? One way that I'm just kind of pushing now towards what's sort of a more reasonable way to do it is to say that, well, and this is a different way of looking at regression, I think, than all of you probably would, but let's say at every point you just basically regress the proportion of responses onto something like the experimental factor. So ignoring context for now. Basically, here's I'm not sure how much to write this on computer science, but here's a kind of stats site way of writing it out. Let's actually say that I'm going to have a beta weight, a coefficient, that's going to be, beta 0 times this dummy variable, which is saying it's 0 if you're in anything but action 1, and it's 1 if you're in action 1, plus beta 1 times beta 2 times A2 plus beta 3 times A3, and then beta or dBn. So basically what I'm saying is, let's actually just do a simple regression where we say, predicting, oh yeah,
Just in terms of time,
yes.
especially because we had a little bit of meeting, just to maybe wrap up in about 3 minutes or
Minutes,
so.
okay, got it, sure.
So we can clear out quickly after that.
Great, I'll do that. Okay. So basically, this is right-hand regression equation is dumb and unnecessary for this case because it's so simple. But here's, I think, how I can define this in a more formally reasonable way, and this is what I'm curious your thoughts on, in a way that generalizes for other situations. But it's basically saying, if you then have these dummy variables, A1 basically codes for whether you did action 1 or not, A2 whether you did action 2 or not, A3 whether you did action 3 or not. If you fit this regression equation, then you get basically these beta weights. And instead of actually just doing this thing that just looked a bit heuristic, you could actually have a policy that says the probability of taking an action, like action 1, can actually be equal to set to be like the beta weight of action 1.
What's the dependent variable?
Oh, sorry, the dependent variable is the response rate.
It's a logistic regression?
Yes.
0, 1?
Yeah. So you could then do beta 1 over the other betas. So what this is actually doing now is a lot more reasonable, and it's actually, you can see where this is coming from. It's basically saying this beta weight is capturing how much being condition A contributes to the reward, to the proportion of people responding, above and beyond the mean. So the idea is this beta weight is capturing information about magnitude. And so you can actually now define your policy in terms of parameters of this regression.
Yeah, but do you insert dummy? Actions, of course, are mutually exclusive.
Yes.
Right? So you insert dummy variable?
Exactly, yeah. So A1 is a dummy variable. Yeah. Yes, ma'am.
Those are green effects instead of personalized effects.
Exactly. I'm just showing you the absolute simplest case possible here. And this is not even interesting for this case. It's just that this approach generalizes nicely for those interactions. But so what is, so basically to kind of wrap up, I guess to summarize what I've done is, the main point I think I made at the beginning was, what I've been working on is a way that you can actually run these kind of algorithms in any real-world technology, education otherwise. And this opens up a new set of questions, like if when we start doing policy for experimentation, we know that our rewards are going to change, in some ways correlated with our rewards were different, if we know they're going to get more contextual information, how do we have a way of doing multi-arm bandits that doesn't just look for the best arm, assuming a fixed reward, a fixed context space? How do we actually have policies that say, I'm gonna kind of minimize harm. I want to keep exploring as much as possible. So I don't want to just keep the best arm. But I'm going to say if two things are not that different, then I'm only going to explore one slightly more than another. If they're really different, well, then I'm going to explore this one a lot more. But it actually is sensitive to magnitude. And I showed one kind of heuristic way that I did that by actually just saying, well, let's just predict what the value of the reward is in A1, A2, A3, and let's just divide them by each other. So the prediction here is 0.05 divided by the sum of all the predictions. That's a right heuristic way. But now what I'm moving towards is actually a more principled way, which is actually saying, well, if you do a regression, where now you get these beta weights that say the contribution of B in each action to outcomes. And you can get beta weights for basically interaction between the action and contextual feature. Then actually that's a new way of setting policies that is actually using this information about magnitude. And just to gesture even further, this actually still doesn't take into account any information about how sure you are. Like this ratio is not the same whether you're at 100 subjects or 10,000. You can actually now think about incorporating into this something like some variable that might say how many subjects you see. So this is a nice way of just saying, how do we take the coefficients regression, whether they're the magnitude beta weights or confidence intervals on what those beta weights are, and actually incorporate them in updating a policy. So instead of proportion to something helps, let's also explore in proportion how much helps plus how confident we are. And so it might get something benefits from some of it from a very different angle.
Thanks. So I think folks can keep talking maybe afterwards, but let's wrap up and go through this now. So let's clean up because I thought we had a room, our spreadsheet says we have a room, but apparently whatever the magical room book is doing.
Yeah, there was this like advanced stat Harvard system, but then I think they sort of silently deprecated.
I see.
And
Well, I mean, all I
possibly
have
carry
is
over
the spreadsheet that.
around here.